Okay, thank you for coming, everyone, today. We're here to present the Caltrans District 1 climate change pilot study. And I'm going to turn it over to Charlie Fielder, the director for Caltrans District 1.
He's right here. Can you hear me okay?
Yes.
Okay, great. Hey, well, thank you, all of you here in Eureka, for attending this presentation this evening, as well as those of you that have attended some of the past open houses we've had on. I also want to say thank you out to Del Norte County, Mendocino, and Lake County. A lot of work has gone into this. The Caltrans staff that's worked on it, the different RTPAs, and then our consultants, GHD, and others. So I want to show my appreciation for that. It's kind of poetic that today is the 50th anniversary of the '64 flood. And so that's something that we take very seriously, and that was an event, a 1,000-year event that people hadn't seen since 1955 maybe, but in all seriousness, it was a significant event that we did not think was going to happen of that magnitude. And that really sets the tone for what we're looking at with the way the climate scientifically is changing. There are things that we recognize that are going to have to be adapting to. And so I really appreciate the effort that was done here on the North Coast to going ahead and tackling this very important issue regarding transportation infrastructure, knowing that there's a lot of other infrastructure that needs to be coordinated with that. But it's setting the tone for the rest of the state. We are doing similar studies now over the next several years in different parts of California, but a lot of it is being modeled after the effort that all of you have participated in here on the North Coast. So thank you for being here this evening. And I'll put it over to Brad there.
Thank you, Charlie. My name is Brad Menham. I'm the Deputy District Director for Planning and Local Assistance. And we're now at the end of a 12-month process to sort of look at, in a pilot sense, climate change and how we would assess the vulnerabilities of our system. We've been working closely with our partners. Next to me is Marcella Clem. And I just wanted to thank a couple of members of my team. Rex Jackman has led the effort, assisted by Jamie Hostler, who's out in the audience. And I'll turn it over to our consultants to do the presentation.
Thank you, Brad. And I just would, and I think Charlie mentioned, but would just like folks to know this presentation is also being webcast to locations in Crescent City, Lakeport, hopefully, and Ukiah. So when we get to the question and answer portion of the presentation, I will put them on speakerphone so that they can ask questions. Like was already mentioned, this project was done collaboratively between Caltrans and the regional transportation agencies. Some of our project partners included ESA, as well as Alderon Laird with Trinity Associates. He brought a lot of expertise for the Humboldt Bay Area region. Today we're going to talk a little bit about the purpose of the project. Then we're going to review some of the information that you may have previously seen on the vulnerability assessment that was done. We're going to talk about the public input that we received in a series of public meetings held in August. Lastly, we're going to go over the adaptation options, talk a little bit about lessons learned, and then next steps, what happens next in this process. So in looking at climate change, historically we've really looked at past data, and we've seen recently some trends with temperatures increasing, but a lot of the work historically has really been past looking, what's happening behind us. We're really at a changing point in time in how we look at and evaluate data. We're starting to look forward. So we're starting to project what will the climate be in the future, and that isn't something that we've done in a long time. And so this study takes advantage of a lot of that work that's really looking at what's happening in the future. And in looking at climate change, we know that there's existing extreme weather events that tell us things are changing and we've got to start taking notice. I've got a couple examples here. The first week of December, we had what's called a king tide. That's the high tide that occurs approximately once per year. So these are photos from December 3rd. The top photo shows the Highway 255, and you can see Indian Islands almost completely underwater. The lower photo shows the Eureka Slough. You can see there you've got some potential flooding by that one property, and then water levels are rising. This was an approximately 9.1 foot king tide. In Mendocino County, these are photos of the Garcia River. And so you can see in the top photo, they've installed a gate. It floods so frequently, they've installed a gate. And in the lower photo, you can see the flooding. And when this is the bridge over the Garcia River on Highway 1, and when this bridge floods, people have to take about a 5-hour reroute to get around this. So this is a pretty serious issue. We're starting to see it now. We anticipate things to get worse in the future. So that's one of the impetuses for starting this study. So what were our objectives in completing this project? Our first objective was to identify and classify the potential vulnerabilities of transportation assets to climate change throughout District 1. The second objective was to identify and evaluate a range of adaptation options to address and identify vulnerabilities at 4 prototype locations. So at this point in time, I would like to turn the presentation over to my colleague, Brett Vivian. He's going to review the work that went into the vulnerability assessment and review some information. Brett.
Thanks, Rebecca. So when we talk about vulnerability, there are a few terms that we commonly use and what kind of went into vulnerability, and that's the criticality of transportation assets, the exposure that those transportation assets have, the sensitivity of those assets to the climate, and those all feed into the actual vulnerability or the assessed vulnerability of an asset. So when we discuss criticality, we're kind of referring to the relative importance. So there's relative importance within District 1 as to how you assign the importance of one road compared to another road, or one segment compared to another segment. The exposure refers to the climate and the geography throughout the district. The sensitivity is the potential for impact, which is a product or is based on the location and the adaptive capacity of that asset. So the vulnerability really consists of an evaluation of the criticality, the exposure or the climate, and the sensitivity or the potential for impact to that asset. In evaluating criticality, we ask ourselves, so what makes one area or one segment of a road more critical than another? This is in Crescent City. This is approaching Crescent City on last chance grade. And this is in Lake County, an overpass, the downtown area of Eureka, and the large spanning bridge over the Eel River. So how do we assess this criticality? We started with an inventory of the assets to assess the criticality. So looking at how many bridges are in a given length of road. Are there overpasses? Are there drainage facilities? How many people use that road on a daily basis? Is it does it lack redundancy? So it's the only access road in or out of an area. How much money has been put into some of those assets? How large is that bridge? And does it access commercial businesses? So in assessing criticality, these assets can be evaluated as consequence or capacity-based. And the consequence-based is, if this road goes out, what are the consequences of that? If this road goes out, does that completely isolate a community? If it goes out, is that cutting off goods to transport along the roadway? In the capacity issue, it's how big is that bridge? How many people a day use that bridge or that segment of road? And so in this assessment of the criticality, we can evaluate different roads against each other and the assets that they contain to come up with a scale from 1 to 10, being least to most in the relative criticality. We did this for all 4 counties within the district. In Del Norte, the main factor for criticality was the lack of redundancy. So the roads that scored highest in criticality were those that were the only ingress or egress out of an area. In Humboldt County, It was mainly due to massive infrastructure such as bridges, and also some of the higher average daily traffic counts within the district. In Mendocino County, it was due to average daily traffic and significant roadway infrastructure, overpasses and underpasses. And in Lake County, it was redundancy, or a lack of redundancy, that scored highest in criticality. When we discuss exposure and the climate data results, we can categorize these in types of change, the scenarios, the climate models. Types of change can be categorized as primary or secondary. The primary types of change are temperature and precipitation. Temperature and precipitation then drives the changes in sea levels, runoff, erosion, flooding, fire, and changes to vegetation. Scenarios are how many emissions will be released into the environment in the future. Again, as Rebecca had said, we used to look back on previous data to figure out what is our designed storm event, or our planning storm event. Now we're trying to look into the future, which is very unpredictable. So there's a high emissions scenario or a low emissions scenario, and then given those emissions, what does that mean as far as CO2 in the atmosphere? How does that affect temperatures? How does that affect this thermal expansion of the seas, contributing to sea level rise? And how does that affect the ice melt? These climate models are global circulation models, so peer-reviewed models that are accepted globally, and then given local topography and geography, we can bring these down to a district size model. The component of temperature. In the models, we see a wide range of temperatures. So there are some models that in a given scenario will predict higher or quicker, a greater rate of temperature increases. And then this increase is bracketed. So it's important to think about, when we plan for infrastructure or assets, the range of values that are possible. If we get different answers from different models, what is a high range and what is a low range, and that kind of brackets what we might plan for, so that we can be conservative as we move forward. So in general, we were seeing from the climate models in 2050 a rise of about 3 degrees throughout the county, and between 4 and 7 degrees approximately by 2100. Now, the extreme temperatures on the top of this graphic, you can see the high emissions scenario. So this is almost like worst case scenario, if you will. We don't see temperatures increase significantly in the coastal regions, but we do inland. And this is showing the increase in days above 95 degrees. So we would be seeing an increase of about 30 to 40 days over 95 degrees, especially inland in Lake County. In low emission scenario, that's more around 20 to 25 days. With precipitation, again, the models vary. Some climate models will predict that it will be drier over the long run. So this is a very long-term planning, that it will be drier. Other models predict it will be wetter. So this doesn't account for, in the dry models, it may be drier overall, but we'll see still very large storm events and large precipitation events confined to a few days or here and there. The dry model would be useful in our planning practices for estimating fire risk, whereas the wet model you'd use to estimate what is the precipitation for planning drainage infrastructure. The runoff is a function of precipitation, and a similar result. In a dry model, high emissions, we see a decrease in runoff. In the wet model and low emissions, on the other end, we see an increase in runoff throughout the district. When looking at fire, Department of Water Resources essentially used a lot of the dry models, so to speak, to estimate the potential fire risk with the lack of precipitation. And you can see that that increases incrementally, so from 2050, it's an exposure. They basically give a rate from 0, where it's not increasing, to 3, where it's a high risk. By 2050, a slight increase, and then by 2100, a significant increase. Sea level rise. Sea level rise predictions vary globally. It really depends on your geographic region and then the geology of the region. So, for example, some of the tectonic activity in Crescent City, the land is rising, whereas around Humboldt Bay, the land is subsiding. So these relative sea level rises are how we kind of quantify them, and Rebecca will give a little more detail on the local sea level rise projections. The coastal erosion, as sea levels rise and storms intensify, that coastal erosion zone moves inwards. So as the cliffs or the dunes erode, there's more room for those waters to move in, especially as the seas rise. And in combination with sea level rise and precipitation events, we can see coastal flooding. So as the seas rise and any infrastructure that currently hold back the sea level or the seas, as those fail, there's more room for water to move in. So an example is around Humboldt Bay, where we're protected very much by levees. Without those levees, and with sea level rise, or as seas get higher than those levees, there's more room for the seas to move in. So we get to quantifying potential for impact. So in thinking about potential for impact, how do we view what is an impact, and what does that look like? Is it a storm event that just creates some traffic delays because of low visibility, or a fire and smoke that is low visibility? Is it debris on the road, shutting down to one lane as opposed to two? Does it actually require some kind of significant, a little more significant maintenance? Does it involve temporary road closures? Or is it complete failure of the roadway? So there's a difficult thing to kind of quantify on a large district-wide sense. So what we did was look to the historical maintenance data to try to figure out how do rain events affect roadways, and where might we see those events. And in looking at this, we took feedback from Caltrans and a database of their historic events and the descriptions that were given to those. And we could think about, so how many times is there an emergency event that happens on a given stretch of road? What was the cost of that, cost per mile of road length? Or just where are we seeing very large events that cost quite a bit? And so in that, we can kind of define the potential for impact. So based on the asset and service sensitivities to the climate factors, the historical maintenance information that we've gathered, and the climate change projections, we can categorize these as reduced capacity, temporary operational failure, or complete failure of a roadway. And the results of this analysis showed that in Del Norte, coastal roads that were near the coast were subject to coastal erosion, flooding events, and in particular, there were runoff on landslide events. In Humboldt, it was the rising seas, so noticing that roadways were at elevations below projected sea levels, and there were significant erosion events or landslides, and then also there was coastal flooding. In Mendocino County along the coast, again, coastal erosion and coastal flooding. And then in inland, in Lake County, we saw potential for flooding due to roads being within the 100-year and less inundation area. So we took the criticality scores from 1 to 10 and the potential for impact scores from 1 to 10, and the product of those came out with your vulnerability. So an asset that displayed high criticality and high potential for impact would thus be a high vulnerability. A high criticality, but probably not going to see a high potential for impact, that decreases the vulnerability score. So these were essentially plotted on this diagram as far as what is the product and the end value when you multiply the score from 1 to 10 of criticality and the score of 1 to 10 for potential for impact. And the vulnerability ratings in Del Norte helped us characterize each county as far as what are the issues that each county deals with and how can we select and what sort of pilot study or what locations can we select to conduct a pilot study. In Del Norte, it was the last chance grade. This was due to the lack of redundancy and because of the runoff on landslides and the coastal erosion. In Humboldt County, Humboldt Bay, the safety corridor between Arcata and Eureka was selected due to its vulnerability to rising seas, as well as the high average daily traffic. In Mendocino, the Garcia River mouth was selected. As Rebecca showed you, there was a picture of the flood inundation, and then the lack of redundancies, the significant travel time to get around that road closure. And in Lake County, the Middle Creek Rodman Slough area was selected for the flooding and also for the lack of redundancy. So I'm going to pass it to Rebecca to discuss a little bit more about those pilot study locations and the adaptation strategies that were implemented.
Thank you, Brett. So we've gone over the vulnerability. We talked about how did we analyze the system in terms of what was critical, how is it going to be impacted, and what are the most vulnerable facilities within Caltrans District 1. And then Brett went over that we selected 4 pilot locations. Wanted to talk about next was the different adaptation approaches that we looked at and the overall process. So the overall process for adaptation was 1, looking at the asset location, then re-looking in a little closer detail at the climate impacts, talking about the different adaptation options, and we'll be going over those in a moment, conducting our preliminary evaluation, getting some tag and stakeholder input, prioritizing those sites, doing a cost analysis, and then the next step from there is to continue to plan. So I'd like to review the different types of adaptation approaches that we're looking at. The first adaptation approach is defend. You can see here in this graphic, you've got a nice fancy hotel. It's nice and big. You know, had this road not be here, it might be washed out. So they chose here to protect this roadway. You can see installed a large culvert riprap. Next, let's look at some examples of the defend adaptation approach. And so you've got construction of flood walls, seawalls, levees, and dikes. You've also got living shorelines. It's a more natural approach, especially on the coastline. It can protect from wave action and protect some of your infrastructure there along the coast. Also, some very structural options, soil nail and retaining walls as another common defend adaptation approach. Next, we look at accommodate. So instead of trying to protect everything and defend, you let it happen. So you plan to let it happen. You can see here they've moved the hotel back. It's on higher ground. They've built a causeway that allows water to go underneath and flow where it wants to. So some accommodation adaptation approach examples: a causeway, floodable bridges, raising bridges and roads. There's also the potential for a bridge over an area, or potentially a tunnel under an area that's vulnerable. Next, we're looking at planned retreat. You know, if you don't think that you've got the dollars or the road isn't used that much, you can plan to retreat away from it. So some planned retreats. This example shows some planning that's going on in Southern California. In the upper graphic, you can see there's a roadway right there along the beach. In the lower graphic, they're showing the future plans. They're going to remove that roadway and look for alternate access to that site, and they're going to be able to restore the beach and allow for the wave run up to be further inland. Another example that many of us here on the North Coast are familiar with in terms of rerouting and planned retreat, this is Confusion Hill. So instead of continuing to defend and try and protect that roadway, they just built they built the 2 bridges and reroute. And everybody has a lot less trouble in the winter nowadays. The next adaptation approach is kind of the no approach, is the forced retreat. So if action isn't taken, at some point in time, as climate change marches forward, you're going to have a catastrophic event that's going to close the road, causing, emergency costs, delays, panic. And some examples there are you're seeing flooding, road closures, landslides, road closures. So in summary, there's really 4 adaptation approaches that we were looking at, categorized as defend, accommodate, planned retreat, and forced retreat. There's also on here policy changes. So there's things that can be done in terms of policies and plans that are in place to start also helping to plan for climate change. And we talk about that a little bit later in the presentation. Next, I'd like to review some of the information that we got as public input at the meetings that were held in August. In August, a series of 4 meetings were held. One was held here in Eureka at the Wharfinger Building. There was a meeting held up in Crescent City. There was a meeting in Fort Bragg, and also a meeting in Lakeport. Those were all live meetings, and we tried to get some input on some of the adaptation planning that was going on. So we had some dot exercises. We put up different adaptation options, and we gave people the opportunity to vote on which adaptation options they liked. And so I'm going to review the results for each of the 4 counties. So in Del Norte County, and these were specific to the pilot sites, because by that point in time we had selected the 4 pilot sites. In Del Norte County, there wasn't a lot to discuss at last chance grade. There was really only the 2 options. So we also talked about what people might think about some adaptation options at South Beach. So at last chance grade, there were 2 options, 63 votes, 100% of the people in attendance at that meeting preferred rerouting the road to defending the road. And it's important to note that people were allowed to vote more than once. And then in terms of South Beach, and the preferred methodology was to reroute the road. People also provided some votes for protecting the road with armoring and or living shorelines, and raising bridges and roads or adding a causeway got about the same. Nobody was open to managing with closures. In Humboldt County, these results are a little more even in comparison to some of the results we saw in Del Norte County. The highest getting vote option was protect roads with armoring and or living shorelines. That got 74 votes, about 36% of the total. People were also in favor of a causeway at about 25%, rerouting the road at 17%, raising bridges and roads about 12%, and there were about 9% of people, or 18 votes, that people thought we could manage with closures or no changes. In Mendocino County, we looked at, or the highest ranking adaptation option was rerouting the road. Next was a causeway. This was followed by 1 vote for raising bridges and roads, and nobody was into managing with closure, and that's understandable. Like I mentioned at the beginning of the presentation, at the Highway 1 crossing of the Garcia River, when that gets flooded, there is no good workaround. And in talking through this project, we learned they close schools. There's all sorts of planning that goes on for that site. So doesn't surprise me it got no votes. The Lake County adaptation option input, about 61% of people there thought a causeway would be a good adaptation solution. 30% of people thought raising bridges and roads would help. About 7% of people were in favor of rerouting the road, and about 2% were okay with managing it through closures. Next, we looked at some of the criteria that we use to rank the adaptation options. So, part of this project was to kind of think through different types of adaptation options and then develop a system to review, rank, and score adaptation options as a tool to kind of help people identify and understand. So we had 7 Adaptation criteria. I'm not going to read through all these definitions, but wanted to just refresh people's memory what went on at those meetings. So we looked at total capital investment. That's the total cost, including planning, design, engineering, environmental, construction. The average annual cost, that's the total cost divided by the design life of the asset. We looked at the usable life, so that's a comparison of the adaptation options design life with respect to the climate change event horizon. So if you're constructing something that only has a usable life of 20 years and your climate change thing is happening in 10 years, you really only have a 10-year usable life. So comparing how long the asset is going to protect you from climate change. The level of performance, so we looked at the existing level of protection compared to the anticipated level of protection. So if you've got an adaptation option that's really a no project, just kind of the wait and see, and you know that there's existing closures and things, that doesn't provide a very good level of performance compared to today. It's pretty much the same, and actually will get worse over time if you don't take action. We looked at the flexibility, so it was important to us to consider what options could you raise higher in the future or expand or make different in the future, because we've talked about the variability in these climate models and you don't know exactly what's going to happen. So if you've got an adaptation option that's more flexible, that you can change in the future, that in the way that we analyze things, that was preferred. We also looked at environmental considerations, so the potential of the adaptation option to either improve, potentially, or impact the existing environment conditions, and this is with respect to an integrity of diversity, abundance of natural ecosystem functions, or habitat. And the environmental considerations was ranked on a scale of positive to negative. So there were some adaptation options that ranked negative just because of their environmental impacts. And then lastly, social considerations. So we've got a transportation system to support connectivity, to support people getting places, to support emergency vehicles, getting access to places. So that was a big component. So that's the potential of the adaptation option to improve or impact the community's social welfare. So if you've got options that allow roads to continue to be closed, they got a really low score for social considerations because they're not helping people improve their existing condition. And then here's a summary of the adaptation criteria ranking that came out of the public meeting. So we've got scores for Humboldt County, Del Norte County, Mendocino, Lake, all the counties come together, and then the TAG and stakeholder group. And it was interesting to see some of the differences in the priorities, across counties. And then our TAG and stakeholder group is made up of people from all counties. Our final scoring, the level of performance, so how well the adaptation option addressed the climate change, was the highest ranking criteria. This was followed by usable life and social considerations, followed thereafter by environmental considerations, then your average cost, your total capital investment, and your flexibility. I think a lot of people might rank that total cost a little bit higher, but it was interesting in this process and the different feedback that we got, that's where it landed. So next I'd like to talk a little bit more about the specific adaptation options at each of the 4 pilot sites. So as you recall, Brett mentioned these are our 4 pilot site locations. We're going to go north to south. So in Del Norte County, so here's a image showing the location of the pilot site, and then here on the right we've got an image of last chance grade. You can see in this photo some of the erosion that's occurring. You can imagine with the increased wave action what's happening there. And then the climate factors for this specific site. So you're seeing sea level rise anywhere between dropping a foot, as Brett mentioned, with the tectonic action in that area, you're actually getting some uplift. So that in combination, you could get actually a decrease up to 19 inches at 2050, and at 2100, you're seeing anywhere between 4 to 56 inches. When we talk extreme precipitation, you're looking anywhere between 2 and 9% change from today in 2050, and anywhere between 1 and 16% change at 2100. And then for extreme runoff, you're looking at anywhere between -6 to -5% change in extreme runoff, and a similar range for 2100. This graphic shows a little bit more about what's going on at the last chance grade site. You can see the impact of sea level rise, then you've got increased wave attack, and that's affecting the toe of the slope there. You've also got the landslide and erosion occurring on top of the landslide. So you can see this is a very complicated site, very difficult to design something to be able to maintain the existing alignment. So the other thing I wanted to mention was that there is an ongoing Caltrans last chance grade feasibility study. The purpose of our study was not to recreate work that others were doing, and the timing was a little bit off. They're not planning to finish their study until June, but wanted to mention what was going on. So they are looking at collecting and evaluating data. They're reviewing previous studies. They're developing a range of alternatives. They're evaluating feasibility of those alternatives, including time, impacts, and cost, and they're developing recommendations. So it's my understanding that some public meetings are scheduled for this project in January on the 26th, 27th, and 28th, and that the study is due to be completed in June of 2050. So we didn't go into a lot of detail evaluating adaptation options in our study for this site, because that study is doing a lot more detailed analysis of what's feasible. But we did want to kind of take a broad look at what could be done. And the other thing that we wanted to take a look at that site was what we call the evaluation of no project cost. So if you're doing nothing, there's still a cost to it, right? Everyone knows that, you know, you go past there and you see maintenance staff all the time, either just cleaning up little slides or, you know, this and that. There's also bigger projects that are going on. So from year to year, you're seeing different types of projects, some year pretty high, some year pretty low. We looked at data from 1989 to 2012. The average annual maintenance cost over that period, so that's, you know, averaging the high years and the low years, was about $1,923,610. And then what we did is we projected those costs into the future. So if you continue to take no action, also accounting for the time value of money, the fact that things get more expensive over time, we looked at, well, what would costs be if there was quote unquote no action or no project. So by 2050, we estimated about $141 million in maintenance costs. Again, just like to reiterate, these are future dollars accounting for some increase in maintenance activities over time, but that's a significant investment. If you look to 2100, it's about $1.3 billion. Again, these are future dollars accounting for increases in maintenance over time, but that's a significant amount. And so when you compare the potential costs for implementing a project with no project, there is a value and there is a, you know, an eventual break-even point for implementing a project. So we did take a look at some adaptation options and kind of rank them theoretically. So the first option was to provide major structural protection. This would involve some sort of high technology solution, approximately within the existing road right-of-way, possibly including retaining walls, some minor realignments, and bridges or tunnels. It's unknown at this point. The feasibility study will determine some of that information. The cost estimate is $1 billion or more at this point in time, very large scale. That'll be refined through the Caltrans study. The second ranked option, or the option that came at scored second, it was very close to the first, was to relocate the infrastructure. This is to construct a full bypass around the area. The cost for that was between $300 million and $1 billion. The last was what we sort of just talked about, was the increase the infrastructure's maintenance and inspection interval and continue to monitor and evaluate. So this is really equivalent to the no project alternative. There's only temporary measures enacted. Repairs are made on an as-needed basis and includes the cumulative average annual repair costs for 20 years and assumes appropriate signage for road restrictions. This had a cost of about $26.5 million. Those are in present dollars, today's dollars, so they're not necessarily comparable to the last graph, but still a significant investment over the next 20 years. Next, I'd like to take a look at the Humboldt adaptation site. So here, again, we're just showing the location of the project. We've got an aerial view of the Arcadia-Eureka corridor. Sea level rise at this site is anticipated to increase between 10 to 26 inches by 2050 and 26 to 70 inches by 2100. That's over 5 feet. And that's looking at the high emissions scenarios that Brett had mentioned. We have the low emission, the high emissions scenario, so somewhat of a worst case. Extreme precipitation is expected to increase anywhere between 1 and 11%. by 2050, and anywhere between 2 and 14% by 2100. Lastly, extreme precipitation is expected to change by -1% to 9% by 2050, and between 4 and 12% by 2100. This graphic shows the potential for coastal flooding. This assumes sort of what we call a bathtub model, so it would assume all the levees break and this is where the water would extend. So you can see there's a really high potential for impact in this area. And the next thing we did is look at some cross sections along the 101 corridor to kind of get a sense of how do different water levels look at these cross sections. For this, we focused in on the cross section just south of the Indianola cutoff. So this first graphic shows this is existing mean monthly maximum water. So that's the high tide elevation that's expected to occur approximately once a month. So you can see where that's at. It's not too bad. The next thing that we analyzed was the king tide. So this is an average king tide. This is 8.78 feet. That's in comparison to the high tide that we had just a couple weeks ago, which was 9.1 feet. And then, so these next series of cross sections are going to build on that king tide water level and kind of show you where the water level is going to get in comparison to the roadway and surrounding land under the worst case 2050 and 2100 scenario. So under 2050, we're looking at the king tide plus sea level rise of about 26 inches gets us to 10.95 feet. And you can see the northbound lane is starting to become underwater. The southbound lane is almost there. And you're starting to have some problems. This next one looks at the king tide plus about 70 inches of sea level rise. And in this case, both the north and southbound lanes are underwater. This is obviously a problem, something needs to be done. It's interesting to note throughout the 101 corridor, the areas south on the southern portion from Indianola Cutoff down to the Eureka Slough Bridge are more vulnerable. The northern portions are a little bit less vulnerable. Our final report has these cross sections for all three locations, and you can see the different impacts through time for those locations. The fact that you've got variable conditions throughout this one stretch does give the opportunity for phasing. So you could do something and kind of deal with the lower stretch now and the upper stretch later. It also brings up in the conversation, the larger picture. We looked at this project in terms of smaller segments. There may be opportunities to look, further south of Eureka and see what opportunities they are. But in this study, we just focused on the one segment. So we did also kind of just test out what it would look like for a couple adaptation options. This first adaptation option is to strengthen the existing berms, protective structures, enhance the railroad grade along the Eureka-Arcata corridor. This option would have the benefit of, you can see here, it not only protects the Caltrans infrastructure along the 101, but it also has the benefit of protecting everything east of 101. So private landowners, there's also multiple utilities located in this area. So this alternative has the benefit of protecting multiple assets. This next one would be to raise the road. So it's kind of, Caltrans working its way through. It's kind of in isolation. You can see the water levels still up there. It in this case also acts as a berm to the properties to the east, but it isn't necessarily protecting some of the other existing infrastructure that's in the corridor. And lastly, we looked at a viaduct or causeway. This is great. We still have access. We can go up and down the road, but we're not protecting any other infrastructure. So everybody else who's got water, gas, electrical lines within this corridor, their stuff's not being protected. So you can see the difference in some of these adaptation options. There's different trade-offs. So in summary, this is the ranked list of how these adaptation options came out when we weighted and rated them. So the number one ranked option was provide protection at the existing elevations. So strengthen, add protection to existing protective structures. Those are the railroad berms, the dikes, and the existing fill areas for about 10 miles. including increasing the height to about 1 foot above the either 2050 or 2100 water level at king tide, depending. And that cost estimate for that, and I believe these are 2050 cost estimates because everything got a little pricier for 2100, was about $121 million. The second ranked adaptation option was to elevate the infrastructure above the impact zone. This would be simply increasing the height of the roadway, again, to about 1 foot above the 2050 or 2100 king tide level. This was for about 6 miles, and this was for the 2050. Cost estimate was about $60 million. Next was elevating the infrastructure above the impact zone, so constructing a causeway about 6 miles at a height of 5 feet above the 2050 water level at king tide. If you're building a causeway, we said might as well just build it a little higher because there's cost efficiencies there. The fourth ranked option was to relocate the infrastructure. For this analysis, it was assumed about an 8-mile reroute to the east. No specific alignment was talked about. That was beyond the level of detail for the study. Based on some of the costs for the Willits bypass, we estimated this at about $350 million to reroute 8 miles of road. The fifth ranked option was to increase the infrastructure's maintenance and inspection interval and continue to monitor and evaluate. So that's sort of the do nothing project somewhat. For this analysis, we didn't go through the effort to look at what are the maintenance costs. This was just simply a cost to for folks to come out, close the road, and do some minor signage. Last, that sixth one is repeated. That sixth one should actually say install intelligent transportation system infrastructure, so signage saying road closed and things like that, and it had a slightly higher cost. Next, I'd like to look at the Mendocino adaptation options. So here we were at Highway 1 at the mouth of the Garcia River. Sea level is expected to affect this location as well. The range in rise for 2050 was between 5 inches and 24 inches. In 2100, it was between 16 and 66 inches. Extreme precipitation was predicted to increase between 2 and 4%, and at 2100 between 4 and 11%. And extreme runoff was predicted to increase between 5.6 to 10.8% in 2050. And actually had a wider range in 2100, maxing out at about 15.8%. This map shows the 100-year effective FEMA floodplain, and then in addition with coastal flooding. So the light blue shows what's the coastal flooding with sea level rise and the 100-year flood. So here's just some photos. Again, this site is experiencing issues today. So they're dealing with flooding today, and it just highlights the need at some of these locations to really be planning for what's going to happen. We've seen that these adaptation options are expensive. They're not cheap, and there's not necessarily going to be money to do everything everywhere. This is definitely a high priority site. You can see here a little bit of what's going on in terms of the climate at this site. You've got sea level rise, so your future waves are higher than they are today. It's anticipated to push, there's a berm at the mouth of the Garcia River. It's anticipated to push that berm, which may exacerbate coastal flooding. Then you've got the floodwaters coming in from the Garcia River. So you've got a really strong connection between the sea level rise and flooding that has the potential to really increase the depth of waters at this site. At this site, we did also evaluate a quote-unquote no project cost. We did estimate the economic value of the loss of function of the road. This is based on detour time in miles. It's based on FEMA standard hazard mitigation values. So in 2050, we estimated that the annual cost, this is just a one-year cost, of about $11.6 million. So that's assuming the road's going to be closed 6 times per year for 12 hours at a time. And so that's the cost to people for gas, for rerouting. That's the cost to people for loss of being able to get where they need to go. And in 2100, that number jumped up to about $33 million. That assumed a closure 12 times per year for 18 hours average duration. So then summarizing the adaptation options that we looked at, again, these are in ranked order. The number 1 ranked option at this site, and it's really close with number 2, within the error margin of our ranking. I didn't put our actual scores up here because they're not very meaningful unless you look at everything. And I'd probably bore you guys to death if I put up all those spreadsheets. It's a lot as it is, so I appreciate your patience. So the first option was to elevate the infrastructure above the impact zone. So that would be constructing a causeway across the Garcia River floodplain and Hathaway Creek at a height of about 5 feet above the 100-year coastal hazard elevation, including 24 inches of sea level rise. That had a cost of about $15.5 million. The second option was to relocate the infrastructure. This is to reroute Highway 1 along Windy Hollow Road, which is a road to the north. That was about $35.5 million, and I know that option received a lot of support, in talking with some of the folks in Mendocino County. The third ranked option was to elevate the infrastructure above the impact zone by constructing a causeway. Let's see, that's very similar to option 1. That was about $14.4 million. And the next two looked at fourth ranked option looked at temporarily restricting the use of the infrastructure. And then the fifth ranked, and that was about $25 million. That was accruing costs over time that we had just looked at. And the last option is increasing the maintenance inspection interval, similar to the ones that we've looked at for other adaptation options. Lastly, Lake County. So here we've got our, I don't know what happened to our sea level rise statistics on this, or our climate change statistics on this graphic. Similar to what we've seen, there's obviously no sea level rise that we're dealing with in Lake County because we're far from the coast, so we're just looking at changes in precipitation and runoff. So here we've got a graphic that shows the 100-year effective FEMA floodplain in this area. You can see where some of the existing problems are, where that crosses Highway 20 and here at County Route 407. Here's some examples of flooding going on at that location. They're dealing with issues today. Here we've got some land movement. They are looking at a large project in Lake County, the Middle Creek Flood Damage Reduction and Ecosystem Restoration Project. You can get updates on it on the internet, and it sounds like they're making progress. They are purchasing some land. They are looking at doing major projects. So it's going to be important, and Caltrans is already engaged. I'm going to ask some questions about this project. This has the potential to address some of the flooding issues and projected flooding issues dealing with climate change. However, it's a really complicated project. Purchasing all that land is going to be tricky. I wish them luck, and I know they're kind of in the middle of it right now. So we looked at, we ranked 4 options in Lake County. The first was elevating the infrastructure, increasing the height of the roadway to 2 feet above the 100-year flood hazard elevation. And the project would incorporate new culverts and drainage features. That was about $49.8 million. Relocating the infrastructure, this was just a 4-mile reroute to the east of the existing Highway 20, and that didn't address the County Road 407. So that Nice Lucerne cutoff that we showed on the other graphic is a highly valued route for the folks in Lake County, and so relocating or the Highway 20 doesn't really address that. The third ranked option was to increase the infrastructure's maintenance and inspection interval, similar to what we looked at other sites. It's about $1 million. And then just simply temporarily restricting use of the roads, again, about $1 million. So that's the summary of the adaptation options. I know it's a lot. Again, we are very, very close to finishing our final report, and it will be up on a website, and I'll give that information at the end. I wanted to go over a couple lessons that we learned. Again, this was a pilot project, right? I think it's really neat that Caltrans District 1 was one of the first or second Caltrans districts in California to move forward to look at this. One of the first agencies to really start going, okay, how is this going to impact our infrastructure? When you think of the value of the roads that they manage, I think it's fabulous that HCAOG and the other RTPAs were partners, because we're looking at transportation assets. There's Caltrans, but that's not a majority of them in the state, and we're going to have to start planning at the local level as well. So again, this is a pilot project intended to look to provide valuable information about the vulnerability of assets and also some adaptation options for some prototype locations, but is also starting to develop a framework that others can use to start doing the same thing. So we wanted to kind of reflect back and go, what did we learn, and what can we take away? So one of the first things that we learned was the criticality assessment is challenging because it's a value judgment. So what's critical for one person may not be critical for another person. So Brett talked about, how we looked at the different factors and how we rated them and things like that. And you can end up, if your driving factors, population or average daily traffic, that can skew some of your results to make those sections of road look more important in comparison to other counties where really if it's your lifeline road, even though that's a small population, it's your lifeline road. And so, there could be some adjustments there. And then we also said in attempting to better focus on criticality to address the challenge, of these value judgments, many potential measures were studied and weighting and built-in redundancy. So when we looked at our final, the criteria we used for criticality, in some cases we had population and ADT and something else that reflected sort of a population type metric. So it created this false sense of detail and overemphasizing some criteria, and it potentially had the effect of skewing weighting. So, in moving forward, I think that's something that people need to pay attention to, is just how you look at that and how the weights and those things come out. Next, there's considerable variability between climate models. No one model is right, and it's impossible to precisely forecast the magnitude and timing of severe episodic events. So we talked a little bit about, the combination of, a king tide and coastal flooding. At the start of the presentation, I showed a photo of the king tides. Well, those photos would have been very different had those king tides occurred about a week later when we had all the rainstorms. You would have seen a different situation. So there's that combination of events. Selecting climate models in light of the variability is challenging. So ultimately, climate models that were more conservative, for example, the wet model, the wet scenario for precipitation, were used to guide assessments related to precipitation. This also brings up the issue of the fact that models are changing all the time. So they're taking these global climate models, different agencies are then using those and revamping them to the local level, and then they're being revamped again even for more local levels, and then they start the process over again all the time. So there will be a need to revisit the modeling as time goes on and double check the assumptions. This is not static by any means. It was also interesting that we conducted this large process, and it may not always be needed to identify vulnerabilities at the local level. When we talked to Caltrans maintenance staff, they knew where the problem areas were. When we started this out, we had a pretty good idea of what our pilot locations would be because we know where the problems are. So in regions where vulnerable assets are well understood, it may be more important to focus funding on specific site and asset assessments in comparison to overall vulnerability assessments. So if you've got a couple dollars, do you look at the whole county, or do you go, hey, Joe Maintenance, where should I be focusing my attention? And they can say, spot A, B, C. So those are just some considerations. Also, we found that the broad-scale vulnerability analysis is helpful for demonstrating the vulnerabilities to state or federal agencies charged with establishing policies that affect local or regional scale entities. So while when you're planning at the local level, you may not need to go through the level of effort that we did for the vulnerability analysis. I think conducting things like that are important because they do start to tell the story on a statewide level. Here is what it's vulnerable in all area. We need to start planning. These are going to be a lot of dollars down the road, and also thinking about how people plan for climate change. So there was value in doing the broad scale analysis. And then in adaptation, so equivalent data sets, such as detailed sea level rise or flood studies that inform site-specific adaptation concepts, were difficult to obtain, and these disparities resulted in less in-depth explorations at sites at different stages of the project. So for example, for our pilot study here in the Humboldt Bay area, the Humboldt Bay Adaptation Sea Level Rise Planning Working Group has done an enormous amount of work studying Humboldt Bay and the effects of sea level rise in Humboldt Bay. So we had really good data looking at 2050, 2100, combining sea level rise with coastal flooding. We didn't have that same level of data at the other sites, so it was more difficult to develop some of the adaptation options. So moving forward, there could be value in conducting more of those in-depth studies at some locations. Lastly, and I'm almost done, and pretty much on time, wanted to talk about prioritized action. So what comes out of this? What do we do next, right? We've studied this, we've looked at some preliminary options, we've thought about how we might do this different in the future. So prioritized actions. The first action that we came up with is coordination with public agencies and private landowners. I've talked a little bit about the interdependency of transportation assets and their protection with protection of other assets, right? As it stands now, sort of that existing levee system is somewhat protecting the Caltrans roadways. As those get breached, the Caltrans roadways are then protecting some of the lands to the east. And also there's all the utilities and things like that. So there needs to be coordination going on. There's opportunities for cost savings as people work together. Another component is the regional local coastal program development and having Caltrans get involved and be aware of what's going on at that, because they've got transportation through everything. As everybody's doing these little studies, it's important to have that regional coordination, because we're all depending on each other in the end to make sure we can get where we want to get. We've got power, we've got water, and that people's private property rights are being maintained. The second was potential changes to Caltrans planning and design policies. So it's going to be important for Caltrans to engage state and federal planning agencies on processes to incorporate climate change into design standards. So right now, things are designed to the 100-year flood. What does the 100-year flood look like in 50, 60 years? If Caltrans continues to design for the status quo, there's little room for adaptation. And so it's going to be important to work with Federal Highways Administration and FEMA to go, how are we going to do this in a uniform manner moving forward? What guidance are you going to give us that people use these design standards and they need to be addressed? So there's coordination that needs to be there to understand what can change. And the other is to support maintenance staff in the collection of detailed data on maintenance activities related to extreme weather events. I've mentioned several times that your maintenance staff on the ground are your eyes and ears to the edge of extreme weather events. They know what's failing, they know what's going on. So providing them, and we found, you saw that Brett presented, we had some maintenance information, and there were some cases, if we'd had a little bit more detail in terms of, what was the rain like a couple days before this, or exactly what was the mode of failure. If you're upgrading that information, in the end, you're going to get a better understanding of what your issues are. And the last action that we recommend was some site-specific risk analyses. We've talked a little bit about the variation in all the models, and also there's variation in the timing of different events. Like I said, you've got sea level rise, but then you've got coastal flooding. What's the likelihood that you're going to get a king tide with a 100-year storm, or there's all sorts of different scenarios. What is the right time or the trigger point at which you really need to have an adaptation option in place? So doing some modeling some uncertainty and risk to determine those trigger points and what action needs to be taken at highly vulnerable locations. So like I said, we have a website for this project. All the previous information from public meetings that we've held in August is up there. Our final report will be up there within, I would say, I promise by Monday. It's very close. It's being worked on as we speak. It is a very hefty document, I will warn you, but if anybody wants to dig in and find a lot of details, I think it has a lot of incredible information. So the website is www.northcoastclimatechange.com. It is now just after 5:10. If anybody has questions, I will take questions. And let me unmute our folks in the other counties. My colleague brought up a really good point. How about we'll go through each of the counties, see if there's any questions. So we'll start, it's hard for me to know who's who on here. But we will start with Mendocino County, because I know which caller you are. So Nafili, are there any questions in Ukiah? Of the presentation?
No, on the final report. Or do we have to download and download? Yeah.
Sorry, I'm looking at my bosses over at Caltrans and HCAOG.
Well, it's on a side note, I don't think the public on the
can repeat it. So the question was, will the RTPAs be getting a hard copy of the report? The report is, I'd say about 2 inches thick. Our plan was to just post it on the internet. People can download it and print it. Brad has something to say as well.
Well, more importantly, the report itself, the document isn't the key parts. We've got the Excel spreadsheets that do all the ranking and criteria. All of that's going to be posted as a bundle. So what you really need is more of the electronic stuff, because if you're going to try to use this in another jurisdiction or to do local road assessment, it's the electronic pieces that are really going to be the most useful.
Does that answer your question? Do you guys have any other questions?
I don't think so.
All right, I'm going to put you back on mute. And I think we'll go to call-in user 3 if you know who you are. So I think call-in user 3, I think that's Tamara in Crescent City.
This is Tamara. Can you hear me?
Yes, I can. Are there any questions?
And user. There is nobody in the room who has the individual question at this time.
Okay.
Just a minute. Do you have a question? Okay, well, you need to come up here and ask. I'm sorry. I thought that we were together, but I guess not.
No problem.
We do have somebody with a question, and she's going to come to the speaker. I'm Gilmore County. Something that puts all of us at greater risk in this area is the fact that our position with relative to the sea is threatened by a tsunami, which, as far as the latest geological information is coming forth, is that we've already exceeded the 85th percentile of an 8-point something happening here. So there's only a 15% chance that we'll get through the next 50 years, according to the latest geological studies. There's only a 15% chance that we'll get through the next 50 years without a cascadia subduction. So that superimposes anywhere from 3 feet to 9 foot change, a drop immediately. So in your scenario, was there any looking at that at all? And then the other issue is, I do think the long-range sea level rise seems to be based on conditions that were pre-2012. Since 2012, now know that 2 Antarctic glaciers have collapsed. Methane is being released in huge volumes. So I would say, even from, the head of NASA, scientists are saying we have, underestimated, and now we are in a reinforcing terrible scenario. And so it looks to me as though your century prediction is really a 2050 prediction. So, and then I don't know where we're going from there, but probably at least double. But that is, things are changing so rapidly. I think all of those factors, as to where we're going to throw our money, greatly influence this whole thing.
And I think those are two really good points. I'll address the first point, or your second point first, in terms of sea level rise. And I think everybody on the phone can hear her because they're all connected to the same phone.
I don't know
Oh. Okay. So her second question related to the fact that that sea level rise or the climate projections are changing. So you're seeing scientists and different studies come out with different assumptions, and some of the more recent studies have shown or seem to indicate that climate change is happening faster than previously predicted, that you're seeing ice melt happening faster, that temperatures are rising faster. And so how does our model account for, or how does our work account for those changing conditions? So we talked a little bit about the fact that we did look at a range of models, and then also in lessons learned moving forward, we know that this is going to be somewhat of a continuous process. So you need to kind of continually reevaluate and look at the different models. This is a newer type of science that we're doing. We mentioned at the start, usually you're looking at the past to determine how you should be planning for the future. Well, it used to happen this way, so we should plan for how it used to happen in the past. Now we're getting to the point where we're looking forward, we're trying to model, we're trying to predict, and there is huge variability in those models, and every year they're getting more information and updating them. So this process is going to have to, for everybody, it's going to have to include continual reevaluation of the climate projections as time goes on. Her first question related to the impacts of a potential Cascadia earthquake event to the analysis that we did here. And again, that's predicting future. There's certain probabilities that people think certain events will happen. If those certain events will happen, here's what they think may happen in terms of land movement. And our study is only able to look at so much related to that. So I think that may be a come as you go kind of analysis. The general information that I hear is there's uplift going on in the Del Norte County area, so that's offsetting some of sea level rise. I think you have to use the best information that you can at the time to move forward, and I think those are good points that they're really hard to plan for. Are there any other questions from? Okay, awesome. And then I think using call-in user 4 is Jesse Robertson in Lake County. Are you there? Are there any questions?
I am here, and we don't have any questions at this point, but I think there was an interest in evaluating the final report to give a little bit more information and maybe have a little bit better defined questions at that point.
Good.
So for the time being, no, but there is an interest in the final document.
Okay, great. Yes, like I said, I promise it will be posted by Monday on that website. So I'm going to put the rest of the counties on mute and see if there's any questions here in Eureka, and then at the end, just in case anything comes back, I'll check in with our remote locations. So just to reiterate, in case folks on the cable access didn't hear, there were no questions coming out of Lake County, but they were interested in reviewing the final report and may have some questions at that time. Right, you want to come up to the mic here?
Ken Sawatsky, I think for those of us in the area, there will be a question here. But the Crescent City problem and the Del Norte problem is imperative. Mother Nature does not want your road there. And it doesn't matter what you do, whether it's sea level rise or something else. I guess somebody said they were going through, 27 foot of asphalt to get down to do repairs that you've already been in. That one's kind of, I hate to use the term, but a no-brainer as far as that bypass goes. Financially, it looks like you're going to save instantly, and my understanding is a 3-year project, so I do totally support the people up there in having that done. So what is the time frame for that? That would be one of my questions. How quickly can we get going on that one? Because that affects all of us with the 101 route. The other question would be, is this PowerPoint going to be available rather than a 2-inch pile of paper for us to go through? Because PowerPoint has most of the information that someone like I would like to have for an executive summary. It saves me a lot of time. That would be appreciated. And then the last thing I have here, as far as it appears in just looking at your sketch without having engineering costs that the most beneficial would be, method is to basically satisfy the Coastal Commission's request for a trail between Arcata and Eureka seems to be a requirement. The upgrade of the infrastructure for the railroad, there are people who would like to see that open for a passenger service, and then that acts as a dike rather than raising your other two. It seems like got a heck of a lot more work, so I guess those financial studies will be coming in. So has that been evaluated at all as far as any of those things and costs, or is that upcoming? That would be my last question.
So I'll address the easiest one first. So the easiest question is, will this PowerPoint be available after this meeting? So this meeting is being recorded by Humboldt Access. We will be downloading, when they post it, we will be downloading that file and posting it at the website. We can also post the PowerPoint at the website as well. So yes, that will be available to you. Brad, do you want to handle the other two?
Let me go ahead and take the last chance grade question, and then I may have to have you repeat the other one. The question about last chance grade was an indication that Mother Nature doesn't like the road on the side of the mountain there, and what are we going to do about that? So we do have an engineered feasibility study underway. That study is intended to be complete June of next year. That is the study you've alluded to, which is looking in more detail just at that location. That doesn't get us started, however. So immediately after that, we are scheduling the work on what's called a project initiation document. That document is the document we can use to go find funding, because we do anticipate it's not going to be an inexpensive proposition. We will carry forward a range of alternatives, obviously, until we get into the environmental process, but we'll need that project initiation document so that we can go to the federal government and the state government and say, this is what we need in order to make this work.
And correct me if I'm wrong, I think your last question related to what's going to happen moving forward at the Eureka Arcata corridor site, where you've got, you know, certain permitting requirements for different things, and there's these opportunities. And so this study that we're doing now, this study now is ending. So this is our final presentation. I can't charge anything this project after December. I want to be done with this project. It's been super fun, but it's been a lot of work. So this study is ending now. You know, this issue isn't going away. People are concerned about the Eureka Arcata corridor, and so I don't know, Brad, if you can say anything specific about future studies that are going to happen. There's obviously tremendous room for coordination between different entities.
I'm not sure I can address the question completely, but let me take a shot at it. First of all, part of our anticipation was that this study would help inform the work that we're doing on the Eureka Arcata corridor. So certainly the information we've developed here, while it's fairly broad in nature, will be something that helps inform that process. The question about the trail and the railroad ballast, acting as sort of barriers, is one that we took up in this study. You alluded to the fact that we're protected by levees and barriers, and we in turn protect other people behind us. One of the key takeaways from this study is we can't make decisions in a vacuum and expect them to work. So if, for example, we were only thinking of the highway, we would probably say, let's just build a viaduct, because we can lift the highway up. Okay, we can build it in our existing right-of-way. Unfortunately, that means that we ignore all the utilities and all the other private property owners and sort of everything around us in solving just our problem. So it's my expectation we're going to have to be working with all of those agencies to deal with it.
Come on up. Thanks.
I have two comments, please. First of which is I appreciate the complexity of all this. This is extremely complex, and just as a citizen, I can appreciate just how much money and time has to go into all of this. Given that, I'm curious about the timeline. I would assume that you probably have a 20-year timeline for implementing projects that really need to be done in the next 20 years. So the question would be, what are the next steps, and how will the process continue to come to some conclusion? I mean, obviously there are some very expensive and serious considerations to be made here. The second question, which is related, is what will be the ongoing public input into this process? I appreciate the fact that you have these hearings and we've given input, but to avoid a Willits bypass controversy up here for any of the other solutions that may come up, how will the public be involved in a final decision, and how long do you think it'll take to get to where we're going to actually start construction on something. Thank you.
I'll put my neck out on this one. They should have heard that on Access, so I should know. Okay. You're right, it is a complex problem. And when you speak of the problem coming to a conclusion, I don't think that's what's going to happen, quite frankly. I think what we're going to be doing next is seeing how do we incorporate what we've learned from the study into our everyday activities, into how we maintain the state system, into how we plan for future projects, and how we look for funding. I mean, all of those things have to be informed by what we learned about climate change in the process of this study. So I don't think you're going to see us come to you and say, this is the solution for climate change in this area or in this stretch of highway. What I'm hoping is you'll see projects that come forward that say, we've thought about the project we need and we've thought about climate change. And therefore, here are the portions of this project that help address that. Therefore, the latter part of your question, which is how do you sort of have input to that, is our normal process of project delivery includes having public meetings and talking about what we plan and how we're going to do that. So I don't see that there's going to be some big climate change category of projects. What you'll see is our regular projects that deal with climate change as well.
Thank you. Yes, please. State your name, too.
My name's Hannah Nielsen. I know that a lot of the shoreline is protected by dikes on private property, and so I was wondering, when looking at the berm as an option for protecting 101, if failure of private property dikes would also be a risk, and if that would kind of counteract the berm proposal for protecting the shoreline. Thank you.
So you're correct that the shoreline is made up of a combination of public and private protective structures, and that if a private protection structure were to fail, that would negate some of the other work. So that's why when we looked at the berm or the protective berm option, that was one of the areas where we really highlighted the need for coordination. That was one of the questions that that I asked when we were developing this option. It's like, hey, if we're looking at this berm and we're counting on the fact that the North Coast Railroad Authority is willing to increase their berm and potentially put a new railroad on top of that increased berm, how would that work? So this study doesn't necessarily answer those questions. I think it identifies the need for greater coordination, especially between public and private, and that moving forward, that coordination will have to happen if they're going to move forward with an option like that. Okay. Come on.
My name is Drew Clark. I had a question about, in terms of like working with property owners, are there any sort of developed methodologies for how that coordination would happen? So how, if there needs to be work that would include working on their land, what's the best process for engaging with them and making those sorts of things happen?
That's a very good question, and engaging with private property owners could take multiple approaches at this point in time. Nobody's specific's been identified, but the flip side, or looking at it, is action needs to be taken. If something doesn't happen, I think those private property owners are going to be affected just like the state and local entities are. So there's that need for cooperation. In terms of a specific process or plan, I don't know if Caltrans has their own specified process. There's lots of different approaches. I think the mutual benefit to everybody for looking at it and for protecting things is going to, I think, help that process. So.
Again, I think my name is Rex Jackman. I worked on this project. I think one of the takeaways from the project that was noted towards the beginning is the importance of site-specific coordination, and in the case of the Arcadia-Eureka corridor, which I think is kind of the main example that we're mostly talking about here, being physically located in Eureka right now. We have our ongoing project, the corridor improvement project, that includes several different advisory committees, as well as there's private property ownership, the Jacobs Avenue, I believe. I can't recall the exact name of the group, that have been informing our process for years and years. So again, it relates with what Brad was saying earlier, that it becomes incorporated into our regular process of project development.
Any other questions? All right, I will unmute our remote locations all at once. Are there any other questions from Crescent City, Ukiah, or Lakeport?
None in Del Norte.
None in Mendo.
Lake?
None in Lakeport.
All right, well then, then I will take this opportunity to thank everybody for your attendance. I want to thank Caltrans and HCAOG for the opportunity to work on this project. This has been really interesting, and I look forward to seeing more about this in the future. Thank the public for attending this meeting and those folks who attended in August and provided input. And I am now going to call this meeting to a close. Thank you.